Go has no classes. Instead, it has three composable tools: structs to hold data, methods to attach behavior to types, and interfaces to express what types can do. Together, they give you everything object-oriented programming offers, without the inheritance hierarchy. This episode covers all three and shows why Go's implicit interface satisfaction is one of the language's best ideas. A struct groups related fields under a named type. Creating values, always use named fields for clarity. Named field syntax is safer because adding a field to the struct doesn't break all your call sites. Positional syntax breaks the moment you add, remove, or reorder fields. Access and modify fields with dot notation. Structs are value types. Assigning a struct copies all its fields. When you need to share a struct or want to avoid the copy cost for large types, use a pointer. Anonymous structs are useful for one-off data shapes, test fixtures, temporary groupings, JSON payloads. Struct tags add metadata used by encoding packages. When you marshal a user to JSON, Marshal reads these tags via reflection and maps field names accordingly. The dash tag excludes the field entirely, useful for passwords. Omit empty skips the field when its value is the zero value for its type. A method is a function with a receiver, a special parameter that binds the function to a type. P-person is the value receiver. P is the name you use inside the method like a parameter. You call it with dot notation. Alice, string. There are two kinds of receivers. A value receiver gets a copy. A pointer receiver gets a reference. Use it when the method needs to modify the struct. Go handles the conversion automatically. You can call a pointer receiver method on a value variable and call a value receiver method on a pointer variable. Go inserts the and or for you. The rule of thumb: if any method modifies the receiver, make all methods pointer receivers for consistency. Mixing value and pointer receivers on the same type confuses callers. Methods aren't limited to structs. You can define methods on any name type in the same package. Go has no inheritance, but it has embedding. When you embed one struct inside another, the outer struct gains all the fields and methods of the inner one. Embedded fields and methods are promoted to the outer struct. You can access them directly. If the outer struct defines a method with the same name, it takes precedence. This is how you override promoted methods. If two embedded types share a field or method name, you must be explicit to resolve the ambiguity. Embedding is not inheritance. Employee is not a person. You can't pass an employee where a person is expected. Embedding is purely about code reuse through delegation. An interface defines behavior as a set of method signatures. Any type that has those methods satisfies the interface. No implements keyword, no explicit declaration. Rectangle and circle satisfy shape just by having the methods. Now you can write a function that works with any shape. This is Go's answer to polymorphism. The function doesn't know or care what concrete type it receives, only that it can call area and perimeter on it. The FMT package's stringer interface is the most common example in the standard library. When you implement string on your type, FMT, println and FMT, printf with %v automatically call it. Interfaces compose, you build larger ones from smaller ones. This is exactly how the IO package works. A type satisfying read closer automatically satisfies both reader and closer to. The any type, alias for interface, accepts any value. Use it sparingly. When you have an any and need the concrete value back, use a type assertion. The two-value form is safe. OK is false if the assertion fails. The single value form panics on failure. For multiple possible types, use a type switch. Two rules define good interface design in Go. Accept interfaces, return concretes. Function parameters should be interfaces so callers can pass any compatible type. Return values should be concrete types so callers get full access to the type's capabilities. Keep interfaces small. The standard library's most used interfaces have one or two methods: IO, reader, IO, writer, FMT, stringer, error. Single method interfaces are easy to satisfy and compose well. Define interfaces where they're used, not where types are defined. If your HTTP handler needs something that can log, define a logger interface in your handler package with just the methods you need. Don't import a big logging package interface. When you implement string on your type FMT, println uses it automatically. This is the FMT stringer interface, one of the most practical interfaces to add to your own types. One subtle trap. An interface value is only nil when both its type and value are nil. A typed nil pointer stored in an interface variable is not nil. This surprises many developers coming from other languages. Structs group related data. Use named fields for clarity. Structs are value types. Use pointers when you need to share or avoid copying. Methods attach behavior to types. Value receivers read. Pointer receivers mutate. Use pointer receivers consistently if any method mutates. Go auto-converts between value and pointer. Embedding is composition, not inheritance. Outer types get promoted fields and methods. Define a matching method on the outer type to override. Interfaces define behavior. Satisfaction is implicit. Have the methods, you're done. Keep interfaces small. Accept interfaces, return concretes. Episode 12 covers error handling, goes explicit error values, wrapping, sentinel errors, and the patterns that make error handling readable. See you there. This course is based on the complete guide to Go programming, available on Apple Books and Amazon. Find it at pixelstech.net/book. See you in episode 12.